Welcome. And here's the pretest. We're going to go through some examples on how to do the pretest because some people might have some different things. There are some questions that I'd like to make known on this pretest. First off, on question number 3, I said not to use your calculator. However, you need to use your calculator to find the zeros. It's not really factorable. You can use a rational root test to figure that out. But you can use your calculator, find out the zeros of that derivative when you figure that out. Make sure you use your sign chart properly when you're doing that. All right, and so for number 3, calculator. So if you want to make that switch, you can do that. All right, the next one is I'd like to go through some of the graphing ones. A lot of people are having questions on those. And there is also another mistake I like to make known. First off, looking at number 4. Okay, right here, we're going to do this one. But before I do, another mistake is that this was 0 for number 5. That one we want to change to 3. Okay, so back to number 4. How can we sketch this graph? Well, we're going to sketch this graph, this function. So we're going to start out by looking at it and identifying all the different values that we have in different things that we're talking about. First off, it asks us to graph, all right, f of 0 equaling 0. So I'm going to plot 0, 0 right here. And from here now, since we have that, we're going to look at f prime of negative 2 and f prime of 1, f prime of negative 9, both all equaling 0. So that means what we have is a horizontal tangent lines. Horizontal tangent lines. HTs at those different values. Now horizontal tangent lines can be maxes or mins, or just horizontal lines themselves. Okay, so at 2 or negative 2, we're going to have some values, and at 1, and then at 9, 1 right there, 2, 3, 4, 5, 6, 7, 8, 9, and 9, 10, 11, 12, and I know we go a little bit farther than that. I'm looking farther on this problem. Okay, so with that information, we're going to now, that's a horrible line, it's all right. We're going to know that we have horizontal tangent lines at this point, negative 2, 1, and then at 9. All right, other things that we know is that we see as we go to infinity, we have it approaches 0. Now this is a horizontal asymptote. Okay, and it's a right end behavior because it goes to infinity. Now, another one we have is as x goes to 6, we realize it goes to negative infinity. Now, when does the graph go to negative infinity? Well, that occurs at vertical asymptotes. So because the limit as x goes to 6 is going to negative infinity, we know at 1, 2, 3, 4, 5, 6, there actually is going to be a vertical asymptote here. Okay. Other part is that we see that f prime of x is less than 0, so that we know that graph of f is decreasing on this interval. So starting at x equal or less than negative 2, all right, we know we have a horizontal asymptote at negative 2. So I'm guessing it's right here. We're going to be going down right here, so it's going to be decreasing. And I'm guessing, just because whatever goes down must come up, if I look over here, where f is going to be increasing, we can see that from negative 2 to 1, it appears that it's going to be going back up. So it's going to be increasing. Okay, so I'm going to graph that. Passes through 0, 0. And if we recall, f prime of 1 is also going to be a horizontal asymptote. So at 1, I'm going to have like a max or min. And what's going to happen then is I'm guessing, oh, what do you know? From 1 to 6, once again, this is going to be decreasing. All right, so we're going from 1 to 6 is going to be going down. And it doesn't say where it intersects, but it's just going to be going down. Probably keeps on going down to that vertical asymptote right there. Oops, hello. Let me try that a little bit better. Okay, so it goes down like that. All right, so it goes like down like so. All right. Continuing on, we can see that, all right, over here, it is also decreasing for all values when x is, all right, greater than 9. Okay, so it's going to be going down at 9. 1, 2, so 6, 7, 8, 9, right here. And we also see that there's a horizontal, so probably looking like this, and it's going to go down. Okay, that way. And we also know from 6 to 9 it's going to be going up. So I'm guessing at 9 itself, we once again have maximum. All right, right there. And it goes down to the vertical asymptote. And we have that. All right, well, let's look at the concavity now. And it says that we're going to be, f is going to be, since this is going to be less than, f double prime is less than 0, f should be concave down. So it should be wearing a frown from all values from 0 to 6. So 0 to 6, it is actually concave down, because if you notice that. From 6 to 12 is going to be concave down as well. So 6 to 12, 6 to 12 is concave down. So 9, 10, 11, 12. So probably want to go a little bit farther. I'm going to change it up. So 7, 8, 9, and 10, 11, 12. So right here, something's going to change. All right, because then I look at this. F is concave up because f double prime is positive from all values less than 0. Okay, so concave down here. All right, or sorry, less than 0. So concave up, like so. Good. That's concave up. And then concave up also from this. Now that's kind of interesting because if you recall, we have a horizontal asymptote. So what's going to happen is we're going to shift like so and create this where it's going to be a point of inflection, concave up, like that. And that is number 4. That's the sketch. All right, we have our horizontal asymptote, the rate and behavior. We have our max and mins at the located points that we wanted. So -2. We can shift it over a little bit. All right, a 1 and then a 9 right there. And that's what we have. All right, very good. Well, look at the other one. What we have is we have another one right here at number 5. Let's check at number 5. Let's start with this right there because this seems to be a big one. All right, that people have problems with. And number 5 we have is, once again, remember that we're changing this to 3 and not 0. Okay, so on your papers, is that we're asked to sketch a graph of this function. We know that f of 0 equals 0, so I'm going to make a graph right here. Once again, f of 0 equals 0, right there. It is continuous and also even. Now, if you know, continuous means there's no holes, no gaps, no vertical asymptotes. Even means that it has symmetry over the y-axis, like a butterfly. Okay, so what we have right here, it says that f of x equals 2x. So now it's a little bit different. From 0 to 1. Now, if fx equals 2x, that means f has to equal, you're thinking, x squared. Yeah, f is actually x squared on that interval because the derivative of x squared equals us 2x, and that goes from 0 to 1. So from here, we have a parabola actually from 0 to 1. So I'm going to draw that. If I plug that in there, we have this. Okay. The next part says that we have a slope. F prime of x equals -1. So that means I have a slope from 1 to 3 of -1. So when I go over here, I have a slope of -1. Go over to 3, have once again a slope of -1 and connect the dots. And we have that slope right there of -1. We then have, it says, a slope of 1 for all x values greater than 3. So, okay, so we're going to go over here. We should have this, and then we should just have a line looking like so. And that's our graph. For the right side, now if you remember, this is continuous and also even, so all these values need to be symmetry, so the same over here, like that. Okay, so we have that one, and then we can graph this one and this one, right, like so. Okay, we get that part. And then we have the next one right there, going up. We graph that last, like so. So that is now a continuous even function with all the different qualities. All right, that is what I need to tell you about the pretest, all the changes. Everything else, remember for this side right here, you may use your calculator, all right, when you're going through. So if you have any other questions, please work together on this, and you can ask me a couple on Tuesday when this is due. But all right, good luck and God bless. All right, bye.